Okay. All right. So just a little bit more on this one, and we've got a pretty cool thing happening down here on example 10. So I like this little moment to talk just for a second about what happens if you try always try a direct substitution first. So what's going to happen? Three things are going to happen. Either you're actually going to get the answer, right? I mean, direct substitution works, doesn't give you any problems. So the answer, the limit is found just by the direct substitution. Or, all right, or you end up getting a 0 over 0, which means we can some sort of fix is available. Okay, all right. Oh, always misspelling. Okay, and then lastly, what could happen is you end up with division by 0. So I could have some sort of number. I'll just put a number divided by 0, which is going to be an asymptote. Asymptote. And so if you didn't have a calculator on you, you would have to check values left and right. It just depends on what they're asking you, right? Okay, so that's cool. Now, all right, so then we've got these two, and they're a little bit obsolete. So we're not going to go real heavy on those too much, but because of L'Hopital's rule, we're able to do some tricks on these two and discover these two limits. But I want to show you something real quick. How it's a little bit. We can make a generalization here. Okay, so let's look at for a second the sine x over x graph. Okay, so they use theta, but let me move this over here just for right now. All right, so if I go sine x over x, there we go, sine x over x, x. Okay, if you do a direct substitution, sine, and we're approaching 0, by the way. So we're approaching 0. As you're approaching 0, the numerator is 0, the denominator is 0. All right, so of course, if I click right here, we're going to see an undefined, I hope. There it is. But as you can see, just by zooming in a little bit, I mean, those values are approaching 1. Okay, so the limit as x approaches 0, only there. Everywhere else, you've got actual answers, right? We got answers. Dividing sine x by x does all those things. And then look how it's like a wave that's being dispersed there, dampening sort of thing. But yeah, the limit there is 1. Now, but hold on, I wanted to show you something else, and we'll do some tricks on this in a second. But as long as those two are identical, it's 1. Now, if it's not, we have to do some stuff. But if they are identical, and what I'm talking about is the inner part of the sine, what we're evaluating sine at, 5 times x. If you divide that by the exact same thing, if those two are the same in terms of x, then the limit as you approach 0 is going to be 1. I mean, it could be anything. Make them both 9. There you go. Now, the problem is that one's stuck because it's stuck inside the sine. So, but this one we could change by multiplying and dividing and that kind of thing. I'll show you that in a second. Okay. Now, another one. All right. So either the 1 minus cosine x or cosine x minus 1, it doesn't matter. Oops. Over x. Okay. Well, again, if I substitute 0 in, you get 1 minus 1 on top. You have a 0 on the bottom. And there we go. So we have an undefined right there, but you can see it's crossing through 0. Now, here's the thing. It does not matter what these two are. Like if I make them the same, sure. Okay. It's going through, not going through 0, but approaching 0. Okay. But it turns out on this particular one, it doesn't matter if they're the same. Oh, you can't see that. It doesn't matter if they're the same. It's just still going to go to 0. And you're like, why is that? Well, because the cosine here is definitely stuck in between 0 and 1. And as I approach 0, it's going to approach 1 no matter what the angle is. All right. So even if you multiply the angle by 5, it doesn't matter. It's still going to that part right there is still going to approach 0. And so we end up with a 1 minus 0. And then on the bottom, of course, if you approach 0, you're going to have 0 also. So every single time on that, you're going to have a 0 over 0 as you approach 0. Okay. So that means, and so, but the answer on every single one of them is the same thing. So let's generalize that here. They didn't do that here, but I kind of want to. All right. So I could also say, just off to the side here. Nope, not a text. Sorry. So off to the side, we could say, I'll go with the blue. That in generalizing this, the limit as theta, we'll use theta again, approaches 0 of sine, and in some multiple of theta, I'll call it A. All right, so A theta, doesn't matter. All right, over that exact same thing, A times theta. Okay, where A is some sort of, it could be any value. It could be any value. Those are all going to equal 1. Okay, but so we got to force those A's to be the same. That one's stuck. We can manipulate that one. Now on this one though, it's a little bit more broad because I can say the limit, okay, as theta approaches 0 of 1 minus, and I'm going to put the A up here, cosine of A theta, just the theta multiplied by something, run out of room, divided by, and it doesn't have to be the same. Now, A and B could be the same, and that's fine, but they don't have to be. So I could say B theta, I was sitting there thinking about A and B being the same, sorry. B theta. Now, A and B could be the same thing, but they don't have to be, and those will always approach 0. Now, okay, so then down here again, on example 8, we're approaching 0. I can show you, using the table. So let's go table, setup, starting at 0 sounds good to me. I'm going to have it ask. Okay, everything looks good. So here we go. So let's go alpha F1 for pretty fraction. Move this out of the way. And what do I got? I got the sine of 2 theta, and we're using x, of course. On top and on the bottom, it's just the theta. Now, which in this case is x. And so I'm going to go to the table, and I'm going to ask for these values. Okay, well, not those. Delete. Okay, what we got? Negative 0.1. Okay, so what I got? 1.99, I guess I could say. All right, so 1.99 there. Okay, let's get a little closer. So over here now, we're going to go that's negative 0.01. Okay, even closer. So on that one, I could say, I go another decimal place just so they look different. We'll go 3 decimal places, 8, and then that one's definitely 1.99. So it looks like we're getting close to 2. But if I hover over it, if I come over here and hover over it, it'll tell me a little bit more. So it's not exactly 2. It's 1 point, but within 3 decimal places it is, right? So I'll put 1.99 just so we can see what's happening. Okay, and 8, 7. We'll just take it on the way out. Now, of course, the 0 is undefined. All right, and then let's head on over here and let's go 0.1. And 0.001, sorry. Oops. There we go. Same values, right? So I've got the 1.99987, just so I can have something different. And then this one's 1.98998. Just like before, we had symmetry, okay? So I suppose you could say that's equal to 2, based on what we're seeing. All right, we got the same values. So I'm just gonna, let's put these in order though. 0.01 and 0.1. And so this will be quick, so I can just go up here and change. I kind of like a few more. Let's get even closer, even though the graph, the chart we have isn't asking us to do that. And then 0.001, and then 0.01, and then 0.1, just to have a few more. All right, and then all I got to do is come over here and change these. What we got? Cosine. So cosine of 3 theta minus 1. As we said earlier, that should approach 0. And so because they weren't heading in this direction, because sure, that's a 3 and that's a 1. But as we saw on the cosine one, as long as there's a 1 right there, it doesn't matter what those are. It's going to go to 0. But we're going to see that in the table. Yep. All right, so here we go. So at the first one, we've got 0.447, and then I've got 0.045. All right, this one does not exist. Oh, and I hope you see that, by the way. If I put the 0 in there, I mean, you can substitute yourself, but just to go there. Yeah. All right, and then on the other side, though, this one kind of cuts through because of the nature of cosine. So where are we at? It's negative. So it's negative 0.045. And then this one is negative 0.447. But the point is this. Okay. So again, these two aren't the same. Let's just kind of see what's happening. We can do an algebra manipulation on that, or a trig manipulation on that in just a second. I'll show you on the next example. But again, we're going to have a shortcut on that later on. So not a huge deal right now, but kind of cool to look at. All right, so looking at the table, looks. I mean, I know these aren't exact, but if I see that, so but we can get some of it. So 0.739, I guess. Yeah, and then the next one is 0.7. Let me go up a little bit. Yeah, 499. That's 0.7499. Yeah, that'll work for us. And getting close to 3/4, right? No doubt about it. And you can kind of see that in the what's happening here. All right, and then likewise we have symmetry here. So 0.7499 and then 0.739. Okay, but it definitely looks like it's 3/4. So you may start seeing a little bit of a pattern on these. I mean, let's just go ahead and say it. You know it's going to be. All right, so let's head back and make sure. Oops, y equals. So head up here, and I've got the cosine, and this time, oh, sorry, it's 1 minus. Doesn't matter if it's 1 minus or the trig function, the cosine minus. It doesn't matter which way it goes because it approaches the same thing either way. 3x. And on the bottom, we have a 2. And then there we are. Okay, so, and I put more than we had to, of course, but because I wanted to see that it truly looks like it's heading to 0. So what we got, negative 0.223. As you get a little closer, it's negative 0.022. We go, does not exist right there. And then it should cut through, and it does. Because remember what cosine and sine graphs look like, and that kind of is following along as we go. We have symmetry on these things. In this case, origin symmetry. And so 0.223. Okay. Good enough. All right, that's it for example 8.